This lab is going to be looking at sedimentary rocks. As usual, there are pre-lab questions to answer, so make sure you go through and answer these before you get started on the actual lab. If you have a rock kit from PCC, you will have these rocks right here, and the numbers are 1, 4, 6, 10, 14, 17, 18, 20, and 25. Now, I'm actually going to remove 2 of these from the set that we're going to look at today. We're not going to look at number 1, and we're not going to look at number 25. And there are various reasons, but basically I'm not real happy with the rock samples that you guys have in terms of how they match with the videos. They really aren't very good examples of what I was hoping for. So we have these that will be from the kit, and then we're also going to include these down here. So in a total, you have 14 samples to try to name for this lab. And I'll talk a little bit about these 2 categories in just a moment, but here are all the numbers so you can be clear. And what to choose from in terms of the names, we're going to have 2 conglomerates, 1 breccia, 2 sandstones, 1 siltstone, and a shale. And these are all under the category of clastic sedimentary rocks. You're then going to have 4 limestones, and those are subdivided into 4 distinct types of limestones, something called a coquina, crystalline limestone, which is sort of featureless, it's just crystalline limestone, fossiliferous limestone, which has fossils in it, and oolitic limestone, which has those little ooids in it that we've talked about before, those little tiny round concretions. Coal is also a sedimentary rock, and there's going to be a sample of coal, and peat is what you have before it turns into coal. It's the organic material. And you're also going to have something called a diatomite. So let's take a look at the classification charts. There are 2, and they're divided based on these 2 main groups of sedimentary rocks. We have the clastic or detrital sedimentary rocks, sometimes they're even called fragmental. And these rocks are classified based on the size of the material in the rock. These types of rocks are formed from physical weathering, so breaking down big rocks into smaller rocks. There's no dissolving, there's no chemical interactions. So they're named on the basis of the size. These are the names you're going to be choosing from. If you have coarse material, gravel, something larger than 2 millimeters, and those clasts are rounded, we're going to call it a conglomerate. If they're angular, we're going to call it a breccia. We have several rocks that have sand-sized particles, and those are sandstones. And in your chart here, they've actually divided out 3 different kinds of sandstones. I just don't feel like we have the time to really go through that, so we're going to just call anything that has sand-sized particles in it sandstone. Then we have a siltstone, which has even finer sized material than sand, and a shale, which is also sometimes known as a clay stone, which is very, very fine. Now, if you really want to know how to tell a siltstone from a shale, you take a little bit of it and you chew it in your teeth. You take a little grit, and if it's gritty, it's a siltstone, and if it's smooth and creamy, it's a shale. Then we have the other group of sedimentary rocks that are produced by chemical or biochemical processes. And these are not named on particle size like those over here. These are named on composition. What is the rock made of? Is it made of calcite, in which case it's a limestone? Is it made of quartz, gypsum, halite, altered plant fragments, or silica? These are the names we're going to choose from for this lab. So we have a crystalline limestone, we don't have a travertine, we have a coquina, a fossiliferous limestone, an oolitic limestone, and no chalk, and then these we don't have examples of. We do have 2 samples in this altered plant fragment category. We have a piece of coal, and we have a piece of peat, which is the organic material before it gets buried and becomes coal. And then we also have something called diatomite, which is made of silica. It looks very soft like chalk, but because it's not made of calcite, it doesn't react with hydrochloric acid. And that's an important thing to note, that all of these limestones, because they're all made of calcite, will all react with hydrochloric acid. So you'll often see the person in the video doing a hydrochloric acid test on the rock, and if it fizzes and if it effervesces, then you have a limestone. If it doesn't, then you either have one of these down here, or maybe you have something from over here. Notice that I highlighted the word crystalline. Most of these are crystalline, meaning they are made of interlocking crystals. There's a few here that say bioclastic, and that means they are made of little pieces of things like shells. And down here is another example. But in general, these are not made of little pieces. These, on the other hand, are all clastic. They're not crystalline. They're all made of little pieces. So hopefully you're understanding the difference between these two groups of sedimentary rocks. Here's the chart that we're going to fill out, and this one already has the numbers in it. So I've just highlighted the ones we're going to do. We're going to skip 1 and 3. You're going to figure out the texture, the composition, then a name, and finally a depositional environment and a justification for why you think that. So let's do number 2 together. Remember that the videos are located on Canvas under the Mineral and Rock video tab, and in this case you're going to go to the Sedimentary Rock Resources. When you click on that, you're going to see 3 different links. One of them are the sedimentary rock videos for this lab, so that's the one that's going to help you with each of these samples. Then there's another site you can go to where you can use something called Giga Macro Technology, where you can zoom way in from an outcrop all the way to a hand sample and look at sedimentary rock. So that's kind of cool. I'm not going to assign anything out of it, but it's kind of interesting to look at. And then this is probably something I should have shown you earlier. It is a great little collection of photos of rocks and minerals. And so in this case, I've selected sedimentary rocks, and so you're seeing the names and a bunch of them, and if you click on any of them, they'll get bigger. And you can also use this site to look at minerals, igneous rocks, metamorphic rocks, and sediments. So that's a great site, and as I said, I probably should have alerted you to this earlier, but it's a very good visual. Okay, back to the actual lab. When you click on this, you're going to have an Excel spreadsheet that's going to give you the 24 little brief YouTube videos to help identify the rocks. Okay, so we're going to start with S2, rock number 2, and you do not have this in your PCC collection. So as you watch the video, which is only 49 seconds, the person's going to describe how there are shells in this rock, and not only are there shells, but they're just almost 100% shells with no cement, nothing visibly cementing them together. This person does a little hydrochloric acid test, and indeed we get bubbles. So that tells us that this is a limestone and it's made of calcite. So we can go to our charts and we can immediately go to this category right here. We then want to decide which of these limestones do we have. So we're going to put calcite as our composition, and now we're going to look at texture, which is in this column. We have crystalline, crystalline, crystalline. It's not crystalline. This is something that's made of shell fragments. So it's either going to be something called a coquina, which is visible shells and shell fragments that are loosely cemented. And poorly indurated means if you hit it, tapped it with a rock hammer, it would probably fall apart. A fossiliferous limestone has various sizes of shells, but this would be well cemented, well indurated. If you tapped it with a rock hammer, nothing would happen. And then chalk is actually some microscopic shells, and it looks very much like chalk on a chalkboard. So that is not what we had. What we had was actually visible shells that are loosely cemented. And so we have a coquina for rock S2. We're going to put the texture as bioclastic. We're going to call it coquina. And then we're going to see where the environment is. And this says a near shore environment. And it also says marine. Marine because we have these limestone shells, which we don't get in fresh water. And near shore because the way that these formed is waves went back and forth and broke up the shells. And eventually they were cemented together. So we have a near shore marine, and our justification is that we have a lot of shells and we know it's made of limestone. Here's the page that includes 15 to 21, and we are not doing 15 or 19. Let's do number 21. So 21 is shown here in the video, and what it is a bunch of rock fragments that are cemented together. And as the person describing the video emphasizes, the cement is really, really clear in this particular rock. Here he has turned it to the other side, and so you can see all these little rock fragments that are cemented together. So we have to assume that we have a rock over on this chart that's made of fragments, right? We just saw a bunch of little pieces. And those fragments were gravel size. They were larger than sand size or these even finer ones. So then we have to decide, do we have rounded rock fragments or do we have angular rock fragments? And in this case, we had rounded ones. So we're going to put that we had coarse gravel, coarse is a size, and that it was made of rock fragments. Going back to this chart, this gives us the name conglomerate. So we put conglomerate in our name, and then we go to depositional environment. And it has two suggestions, an alluvial fan or a mountain stream. And I think either one would be fair enough. I'm going to choose mountain stream, and my justification is because the rocks are rounded. And in an alluvial fan, they might not be very rounded. And the overall rock is poorly sorted. There's a lot of different sizes. This time we're going to do rock S20. And this is one that you have in your rock kit if you happen to have one from PCC. So let me show you my S20. Oh, do it the right way here. And what you should do for each of these rocks that you have at home as you're watching the videos is take your hand lens and look very carefully at them and see if you can see what the person is talking about. Now in this case, I see very, very tiny grains of minerals. They are smaller than sand, but I can see them. So they might be what I would call a silt size of grains. Okay? As he describes this rock, he explains that it does not react to hydrochloric acid. He takes a hand lens and he looks very closely at it like I just did, and he sees individual grains. It was hard for me to get a picture since this is a video, but you do see individual grains. Because we have actual grains that we see and they're about silt size, we're going to say that the texture is a silt size texture. The compositional notes would be a massive rock of silt size particles, dominantly quartz and accessory clay minerals. Now this is so fine we really can't tell that. But what we'll put on our chart is that we have fine grain texture and we know our composition is mineral fragments. We want to have a name, so we're going to call this a siltstone. So we put that in the name. And then the depositional environment here, again, is giving us two choices. Fluvial, which means deposited by a river, or marine abyssal, which means very deep in the ocean. Abyssal means deep. And because we don't see any cross beds or structures, I'm going to go with the marine abyssal. And my justification is that this is a very well sorted rock. So just to clear up what we have to look for, we did one of the conglomerates, we did the siltstone, we did one of the limestones, which was the coquina. So you have 11 left to try to identify. And remember that there are post-lab questions. Good luck, and be sure to ask if you need help.